Are you ready for a groundbreaking discovery that could change everything we know about Mars? NASA has just announced that liquid water has been found on the red planet. This incredible finding has huge implications for the possibility of life on Mars and the potential for future exploration. If you're as excited as we are about this discovery, don't forget to hit that subscribe button and join us on this journey of exploration and discovery. Let's explore the wonders of the universe together. What is Mars? Mars is the fourth planet from the Sun in our solar system and is often referred to as the red planet due to its reddish appearance in the night sky. It is a terrestrial planet, meaning it is primarily composed of rock or metal and has a thin atmosphere consisting mostly of carbon dioxide. Mars is known for its many geological features, including vast deserts, towering mountains, and deep canyons, the most famous of which is the Valles Marineris, a canyon system that is over 4,000 kilometers long. Mars is also home to the largest volcano in the solar system, Olympus Mons, which stands over 22 kilometers tall. Mars has been the subject of much scientific study and exploration, with numerous missions sent to the planet to study its geology, atmosphere, and potential for supporting life. How Mars used to be. Almost all water on Mars today exists as ice, though it also exists in small quantities as vapor in the atmosphere. What was thought to be low-volume liquid brines in shallow Martian soil, also called recurrent slope lineage, may be grains of flowing sand and dust slipping downhill to make dark streaks. The only place where water ice is visible at the surface is at the North Polar ice cap. Abundant water ice is also present beneath the permanent carbon dioxide ice cap at the Martian South Pole and in the shallow subsurface at more temperate conditions. More than 5 million chem3 of ice have been detected at or near the surface of Mars, enough to cover the whole planet to a depth of 35 meters, 115 feet. Even more, ice is likely to be locked away in the deep subsurface. Some liquid water may occur transiently on the Martian surface today, but is limited to traces of dissolved moisture from the atmosphere and thin films, which are challenging environments for known life. No large standing bodies of liquid water exist on the planet's surface, because the atmospheric pressure there averages just 610 pascals, 0.088 psi, a figure slightly below the vapor pressure of water at its triple point. Under average Martian conditions, warming water on the Martian surface would sublime, meaning transition directly from solid to vapor. Conversely, cooling water would deposit, meaning transition directly from vapor to solid. Before about 3.8 billion years ago, Mars may have had a denser atmosphere and higher surface temperatures, allowing vast amounts of liquid water on the surface, possibly including a large ocean that may have covered 1/3 of the planet. Discovery of water on Mars. An international team of researchers has found new evidence for the possible existence of liquid water beneath the South Polar ice cap of Mars. The results published in the journal Nature Astronomy provide the first independent line of evidence, using data other than radar, that there is liquid water beneath Mars' South Pole. The researchers, led by the University of Cambridge with involvement from the University of Sheffield, used spacecraft laser altimeter measurements of the shape of the upper surface of the ice cap to identify subtle patterns in its height. They then showed that these patterns match computer model predictions for how a body of water beneath the ice cap with earlier ice-penetrating radar measurements that were originally interpreted to show a potential area of liquid water beneath the ice. There has been debate over the liquid water interpretation from the radar data alone, with some studies suggesting the radar signal is not due to liquid water. This study gives the best indication yet that there is liquid water on Mars today, because it means that two of the key pieces of evidence we would look for when searching for subglacial lakes on Earth have now been found on Mars, said Frances Butcher, second author of the study from the University of Sheffield. Liquid water is an essential ingredient for life, although it does not necessarily mean that life exists on Mars, Mr. Butcher said. To be liquid at such cold temperatures, the researchers noted that the water beneath the South Pole might need to be salty, which would make it difficult for any microbial life to inhabit it. However, it does give hope that there were more habitable environments in the past when the climate was less unforgiving, they said. Like Earth, Mars has thick water ice caps at both poles, roughly equivalent in combined volume to the Greenland ice sheet. However, unlike Earth's ice sheets, which are underlain by water-filled channels and even large subglacial lakes, the polar ice caps on Mars have until recently been thought to be frozen solid to their beds due to the cold Martian climate. In 2018, evidence from the European Space Agency's Mars Express satellite challenged this assumption. The satellite has an ice-penetrating radar called MARSIS, which can see through Mars' southern ice cap. It revealed an area at the base of the ice that strongly reflected the radar signal, which was interpreted as an area of liquid water beneath the ice cap. However, subsequent studies suggested that other types of dry materials, which exist elsewhere on Mars, could produce similar patterns of reflectance if they exist beneath the ice cap. Given the cold climate conditions, liquid water beneath the ice cap would require an additional heat source, such as geothermal heat from within the planet, at levels above those expected for present-day Mars. The combination of the new topographic evidence, our computer model results, and the radar data make it much more likely that at least one area of subglacial liquid water exists on Mars today, and that Mars must still be geothermally active to keep the water beneath the ice cap liquid, said Professor Neil Arnold from Cambridge's Scott Polar Research Institute, who led the research. On Earth, subglacial lakes affect the shape of the overlying ice sheet, its surface topography. The water in subglacial lakes lowers friction between the ice sheet and its bed, affecting the velocity of ice flow under gravity. This in turn affects the shape of the ice sheet surface above the lake, often creating a depression in the ice surface followed by a raised area further downflow. Analysis revealed a 10 to 15 kilometer long surface undulation comprising a depression and a corresponding raised area, both of which deviate from the surrounding ice surface by several meters. This is similar in scale to undulations over subglacial lakes here on Earth. The team then tested whether the observed undulation on the surface of the ice could be explained by liquid water at the bed. They ran computer model simulations of ice flow, adapted to specific conditions on Mars. They then inserted a patch of reduced bed friction in the simulated ice sheet bed where water, if present, would allow the ice to slide and speed up. The researchers also varied the amount of geothermal heat coming from inside the planet. These experiments generated undulations on the simulated ice surface that were similar in size and shape to those the team observed on the real ice cap surface. The similarity between the model-produced topographic undulation and the actual spacecraft observations, together with the earlier ice-penetrating radar evidence, suggests that there is an accumulation of liquid water beneath Mars' south polar ice cap, the researchers said. This magmatic activity occurred relatively recently in the subsurface of Mars to enable the enhanced geothermal heating needed to keep the water in a liquid state, they added. In conclusion, the discovery of liquid water on Mars is a groundbreaking achievement for NASA and a major milestone in our search for life beyond Earth. This finding suggests that the red planet may have the conditions necessary for microbial life to exist, and opens up new avenues of exploration for future missions to Mars. As we continue to explore the mysteries of our neighboring planet, we may uncover even more surprising discoveries that will reshape our understanding of the universe and our place in it. So stay tuned and be sure to subscribe to our channel to keep up with the latest developments in space exploration. Who knows what amazing discoveries we might make next?